Question 12 part A is matching graphs to the right components. So it shows how resistance varies with temperature for three different components: a wire wound resistor, a thermistor and a superconductor. So hopefully you can spot at a glance which of those three has a resistance that gets smaller when the temperature gets higher. And you should also be able to spot which of those has got a resistance which very dramatically drops to zero at a certain temperature. So it should be easy enough to sort those out. My version of part B says the metal wire used to manufacture the wire wound resistor has a resistance per metre of 30 ohms and a diameter of 0.20 millimetres. Yours have got different numbers. Calculate the resistivity of the material from which the wire is made. So it's resistivity. So if we can't remember the formula, we look on the data sheet, and the data sheet gives us a formula for resistivity. Rho equals RA over L. So to know resistivity, we've got to know R and A and L. If we look at the question, it doesn't actually tell us the resistivity of the whole wire, and it doesn't tell us the length of the wire either. It tells us the resistance per metre. Now, if you want, that means you can use this formula where you can put that R is 30 ohms and L is 1 metre. You get the numbers out right. But strictly speaking, what it's told you, when it says the resistance per metre, it's actually told you what R divided by L is. Dividing means per. So R divided by L is resistance per unit length, resistance per metre. So the 30 ohms is R divided by L. So you just need to multiply that by A. So let's find A. I'm going to use pi r squared. We have to have a check. What information has it given? It hasn't given you the radius, it's given you the diameter. Which seems awkward, but it's sensible, because if you were measuring a wire, you wouldn't measure its radius, you would measure its diameter. So we've got to remember to halve that diameter. So if the diameter is 0.20 millimetres, the radius is 0.10 millimetres. But that's millimetres. It should be working in metres, so let's put times 10 to the minus 3, and then remember to put a bracket around that before we're squaring it. So 0.1 times 10 to the minus 3, that's actually 10 to the minus 4. If you square it, it's 10 to the minus 8. Pi times 10 to the minus 8, that's 3.1 times 10 to the minus 8 metres squared. If you don't believe me, do it with your calculator. So now resistivity, it's R over L, which we know is 30, times the area, 3.1 times 10 to the minus 8. We could use our calculator, or we could just be able to multiply by 3. 3 times 3.1 is 9.3. There's a 10 there and a 10 to the minus 8 there, so 9.3 times 10 to the minus 7 ohm metres.